Hello friends, welcome to Unacademy, which is the largest online education platform for GATE Computer Science and Information Technology. Okay, today we have a very important session as usual. This is the new topic in compiler design, that is a code optimization techniques. And let me introduce myself before starting today's session. And we have seen so many things in the previous sessions, and this is the last session. It's not last session, it's mostly is the final topic in compiler design, just knowing about the code optimization techniques. Okay, if anybody is not aware about my introduction, this is my name, Mallesham Devasane. I'm verified educator on Unacademy. So this is my referral code. If you are preparing seriously for GATE exam or any other exam like ESE or any other exam, and please use DEVALIVE to join Unacademy for accessing my free classes. And I'm going to take so many interesting classes that you can find from this one, unacademy.com/DevaGateCSC. So please visit this profile to access all my free classes on Unacademy. And if you look at my profile, I have worked at various institutes and I have completed MTech from IIT Bombay. So far I have more than 12 years of teaching experience for GATE aspirants. Now here, if you look at the courses on Unacademy that I have taken so far: C programming, TOC, compiler design. So this is my short description, and this is how you can access all my free classes on Unacademy, DEVALIVE. And I have taken more than 370 classes till today, and all you can access just using DEVALIVE, which are going to be completely free. And also, if you want to take the subscription, then use DEVALIVE to get 10% discount. Okay, these are my free classes on Unacademy. Like you can access TOC, compiler, algor, revision of those subjects too, and so many practice sessions as well as guidance classes and daily practice problems, as well as free test series for GATE Computer Science and IT guys, and doubt clearing sessions. So many are completely free, and just come to Unacademy and access all those free classes using DEVALIVE referral code. Okay, so how do you access the Unacademy courses? Use this URL to come to Unacademy, and please log in and use DEVALIVE in case if you require a code to access. And this is our goal to choose, and you can search my name to access the free classes. And if you are interested to take the subscription, click on get subscription. Okay, now there is a new subscription which is iconic subscription, and which is more popular today to crack the exam. You will have all benefits of Plus. Then what benefits are there in Plus, I will discuss slowly. And apart from that, you will have a personal coach and planner, test analysis, and separate study material, one-to-one guidance. And these are the benefits of Plus. You have best educators, and you have live classes, interactive, and you will have structured courses, and including the material and PDFs and live tests and quizzes. These are the benefits by taking the Plus subscription. Additionally, you have these benefits that I have told just now: the study planner, separate study material, and test analysis, personal coach, and one-to-one interaction with your educator. And if you look at educators from GATE Computer Science and IT, and we have many more, and we have these many educators who are very popular and taking the courses on Unacademy. If you take the subscription Plus or iconic, you are completely free to access any course from any educator which I have listed, and many more are there on Unacademy. So all of them are completely free to access. And these are the new initiatives that we have already taken. There's doubt clearing batches for GATE 2021 and GATE 2021 CS and IT batch, and rank booster batch, and likewise you have so many batches on Unacademy. So you are absolutely free to access any course, any batch once you take the subscription. Yeah. So what are the benefits that you have? Structured courses from every educator, and multiple courses for same subject. Study as per your interest, learn from top educator, and study with proper planning and enjoy learning without losing the confidence. Day by day you will gain the confidence and unstoppable and unimaginable journey throughout your preparation. So these are the main benefits of taking subscription. If anybody is interested to take the subscription, look at the plans for the plus. Okay, so 1 year, 1.5 year, 2 years, as per your interest you can take the subscription, but you can use the code referral code DEVALIVE. And Iconic also, you have two popular plans, 1 and 2 years, and you can see the amount here. Choose this referral code to access and to get the subscription. And on this channel you have already so many subjects we have completed, and you can access all of them completely free now, and also so many educators are going to join and will be knowing soon. Okay, let's begin. And guys, hi everyone, please like this session. Yeah, Vash, good evening. Seema, good afternoon. Satyajit, good evening. Yeah, good evening guys. Yeah, so solution I will post in the group. Satyajit, please keep connected. Fine. So in this session, in previous session what we have seen: lexical analysis, syntax analysis, semantic analysis, and intermediate code generation, as well as code optimization and code generation that we are going to see soon. So code optimization and code generation we don't see much, we'll just see the details, theoretical details of the code generation. Okay, so main target is to understand the code optimization now. This is the newly introduced topic in GATE, but which is already the part of compiler design, which was the part of the compiler design. Yeah, Vaishnav, good evening. Now what we have in this code optimization, we are going to see one by one. This code optimization can be applied on high level code optimization, guys. So what do you mean by high level? So on C language you can apply the code optimization. Like if you are using any tools like Eclipse, NetBeans, Dev tools, and they can also optimize your code at high level. And in compiler we do on intermediate code, and we also do on assembly level, because code optimization within the compiler we have two things: intermediate code optimization and assembly level optimization. But before the compilation, that using the editors you can also do high level optimization, but high level optimization is not the part of the compiler, guys. Yeah. Okay, so we have three types of optimization. High level, basically you can see C, C++, so many other languages. An intermediate code like 3 address code you can use, or SSA code optimization. And assembly level, it's assembly code we are talking about. Fine. So let's talk about basically how do you apply the code optimization when you are looking at the program. Because you are going to draw the control flow graph in compiler after intermediate code generation. If you want to do the code optimization, or if you want to do the code generation, you may draw the control flow graph, or you may analyze the program. So here you need to do the statement level. Sometimes the code optimization can be applied at statement level, and sometimes the basic block level. In the previous session we have seen the basic block is the maximum sequence of instruction where control enters at leader and control leaves only after the last statement. So we have seen that was the basic block level, and sometimes code optimization can be applied effectively on basic block. Sometimes we do on loop optimizations, and some other optimizations you can apply at loop level, and some procedural level, that's function level. Within the function also you can apply. Every function you draw the control flow graph and you can apply on such functions. And program level, basically whole program, this interconnection between the functions, where you can say that it's a global code optimization, global analysis is required. Okay, there are various code optimizations, remember that. But what kind of code optimizations we are looking at, we will see slowly. And when you look at the code optimizations, those many code optimizations you can divide into 4 categories. One is local optimization, Like local optimization can be applied on within a function, like not within a function, within a block, basic block, or within a loop, few basic blocks. Intra procedural, that is within the function, whole function I can look at. Interprocedural, that between the functions we can talk about. Global optimization, you can look at whole program, that what kind of optimizations you can apply. So when you learn the code optimization techniques, you might work on doing the local optimizations, or you might work on doing the within the function, or you might work on between the functions, or you might work on whole program analysis. So when you are analyzing the program, you can do at different ways to optimize. So I have told you 3 points, you can look at that. The first one is about you can do high level or intermediate code or assembly level. Second, the optimization, you can look at only one statement or few set of statements or few basic blocks, and or you can see whole function, or you can see at program level. And that I have categorized into 4. Now let's look at, without wasting our time, then the code optimization techniques that we are going to learn. These are the basics, guys, without analyzing much about the program. It's a basics of the code optimization. Remember, basics we are going to learn today. So code optimization techniques. What kind of code optimization techniques we are going to look at? The constant folding, and guys, this is the constant propagation. This is the constant propagation, and strength reduction, and algebraic simplification, and common subexpression elimination, dead code elimination, and loop optimization. In the exam, what we predict, and tomorrow we are going to see data flow analysis. But today we are going to see the basics of code optimization, which can help you at any point of time during the program analysis. Remember, these are the basics before starting actual optimization techniques. Okay, are these individual programs or is it one program? It depends on your choice, right? We can combine all these code optimizations into a single program. This can be applied recursively on the same program. Yeah. So let's begin the one by one to understand how the code optimization works basically. Okay, let's start the constant folding. So I'm talking about very simple code optimization technique, constant folding. This can be applied on a single statement. How could you do that? Suppose you have x is equal to something like 2 into 3 plus y. High level you can do high level or intermediate code, it's your choice. If you have this one, what you get here, if you optimize, x is equal to 2 into 3 6 plus y. What is the advantage of doing this one? You have saved the multiplication. No need to do the multiplication now, because multiplication is costlier at runtime. Now you just need to store the 6 somewhere. Previously 2 and 3 required to store somewhere, and you need to do the multiplication. Now we save the time as well as we save the space. So when we are applying the code optimization, there could be 2 targets. Either you might be focusing on time or space, sometimes both. That depends on optimization we are going to apply. Fine. This is the one technique. The 2 into 3 previously we required to multiply. Multiplication we required to do. Now no multiplication required, just with addition. This can be implemented using just add and move if required. Here you require multiplication and addition. It is the costlier basically. But whenever you have the constants, you can fold them to save your time and space at runtime. So this can be done either at high level or it can be done at intermediate code level, guys. So this is one easy technique, and whether it is multiplication or addition, subtraction, anything is fine, division, you can all do at compilation time. This is at compilation time. Okay, next one, copy propagation. There are 2 kinds of copy propagation, guys. There are 2 kinds of copy propagation. One is you can propagate the constant, and another one is you can propagate even variables too. So how is that possible? Let's see. Suppose you have x is equal to and y is equal to x multiplied with a. You know, this is either you can assume high level, or you can assume intermediate level, or you can assume even assembly level. Assembly level also you have move x comma to a multiplication of x comma a. Right? You can assume at any level. And what happens? You can simply write a code y is equal to 2 multiply with a. And further this can be optimized using other code optimization techniques. But by applying the constant propagation, these two we propagated wherever x is there. So replace x with 2. Right? Replace, because x has no other job, only it has the 2, which is a constant. You can propagate that constant to wherever you see the x in the code. So you can delete x is equal to now, because x is going to be dead after this. Fine guys, clear this point? So what is this? Yeah guys, please don't forget to like the session. Right, I'm requesting everyone, please like this session if you are watching this video. Okay, next one, what is variable propagation? Sometimes what we do, x is equal to b and x has no other job, then what you can do? Now previously you are replacing 2, now you replace b wherever you see x. Okay, now you can write a code y is equal to the b multiply with a. Here we propagate variable. We propagate variable. Just renaming the existing variable simply. Clear this point? It's called as variable propagation. So these two kinds of propagation can save a lot of time at runtime, because so many statements will be deleted if you can detect constant propagation or variable propagation. What happens after this? The x is equal to x is equal to b are going to be deleted because they don't need anymore, because we have replaced x with its job. Clear guys? It is copy propagation. Copy propagation. In the exam they may ask, they will give you code. Can I apply the copy propagation on this code? Can I apply constant propagation on this code? And directly you may not. After constant propagation, maybe you can apply constant folding. Look at the combination guys. Sometimes it could happen. They may give you small code. Look at this. X is equal to 3. Y is equal to x into 2 plus a. This is your code. And they may ask, what are the code optimizations are possible here? What are the code optimizations are possible here? Okay, first one, you can apply this constant propagation. Yes, so you will get the first one. You get y is equal to, that is 3 into 2 plus a, and the second one you can apply. Here I applied constant propagation, but now after that what do you see? You can apply the constant folding. Yes or no? You can apply now constant folding guys. This is very important. Y is equal to 6 plus a. Now you can apply the constant propagation as well as constant folding, but one after other is fine. So this is kind of possible questions in the exam where they will simply ask what optimizations are possible in the code. Just you have to answer, choose MSQ. Okay, one is the constant propagation, or they can say copy propagation, that's fine. Another one is constant folding. Sometimes different optimizations are also possible. You need to understand the various optimization techniques to speak about them. So far we have seen only 2 optimizations. Clear this point? So far we have seen 2 optimizations. One is a constant folding, another one is copy propagation, in which we have 2 optimizations. One is the constant you can propagate, and others you can apply variable propagation also. Fine. Now next, algebraic simplification. This is the third technique. Okay, what is this algebraic simplification? And when you look at high level, I am talking about, when you look at y is equal to, sometimes we write x plus a, and z is equal to y minus a, and then w is equal to then z into b. Now what kind of simplification you can do here? And really, if you are looking at 3 address code, it's very difficult to understand. But when you look at an expression, the actual expression, when you write in reverse, when you scan from bottom to up, you will understand, oh, w is equal to z into b, and z nothing but y minus a, and y nothing but x plus a minus a. And here, if you look at the algebraic laws, the plus a minus a get to be cancelled, so this is equal to x star b. And guys, this whole code simply converts to the w is equal to x star b. That's all. The whole code is converted to simply x star b. So the complete code is just equal to this one. Here, what optimization I have done, guys? I have not folded, I have not propagated, but what I have done is a cancellations. This algebraic simplification, guys. In algebraic, there are so many simplifications, and this is one of them, cancellation. We will also see next strength reduction. We'll also see next strength reduction. There you will understand another kind of simplification. So this is also very important in code optimization. Then when do you apply, how do you apply, that depends on the code, but how do you understand this algebraic simplification? When you look at an expression, you will understand what kind of simplification you can apply, what kind of simplification. Clear this point? This is one of the simplification in code optimization. Now another kind of simplification, which is the fourth technique, but you can also consider it is inside algebraic simplification, but strength reduction, most important thing is it replaces costlier instruction with cheaper, costlier statement with cheaper, Fine. So what kind of a statement is that? Example, suppose I have x is equal to y multiply with 2. Multiplication is costlier, right? Multiplication is costlier. Then it's better to do addition if you want. Y plus y is also 2y. Or you can do x is equal to, if you have left shift operator, you can also do that. These are cheaper compared to the multiplication, because multiplication is costlier, it requires more resources and requires more time. This is cheaper one, and this is more cheaper than, but if your system supports the shifting, then you can also use left shift operator to perform that, and this is costlier. Everybody, so this is one of the kind of optimization when you are multiplying with 2 or 2 powers, basically 4, 8, 16, 32, you can do them by shifting. Okay, and second one, if you are doing the division, example x is equal to y divided with 4, and basically this is equivalent to y right shift by 2 bits. If you right shift by 2 bits, you automatically divide by 4, because when you are shifting, the bit automatically by 2 happens. Everybody knows that, I think. The same as, what is the meaning of this? If you have any binary number, then x left shift by 1, it represents x multiplied with 2 power 1. If you are doing right shift by 1, it's nothing but x multiplied with 2 power minus 1. So in general, if I do x left shift with 5 bits, it is equal to x multiplied with 2 power 5, 32 guys. And here x right shift by 5, it's nothing but x multiplied with 2 power minus 5, which is nothing but x by 2 power 5. Okay, these are the important optimizations in strength reduction, guys. Strength reduction means replacing costlier instruction with cheaper one. So if you see any costlier instruction, if you have any corresponding cheaper one, you can do that. But all these techniques should be implemented before writing the compiler, so the compiler cannot update the optimizations later on. So that is the reason we separate the front end from the back end by separating the code optimization, because code optimization day by day they are going to change, right? We can patch this code to the existing compilers if you can separate this code optimization from front end and back end. So this is the most important for so many compilers today. All the compilers, they can use the same kind of code optimization techniques if you can write the universal representation for intermediate code. Yes, fine guys, this is one kind of optimization. Now dead code elimination, and tomorrow in the next class I'm going to help you how dead code can be eliminated using live variable analysis. That is a different strategy, guys. That is a program analysis. Now we are not doing program analysis, just a few statements or one statement we are doing analysis, remember that. But actual program analysis is little bit lengthy. Okay, what is dead code elimination? In case I have a code, look at that, x is equal to a into b and y is equal to a plus c and z is equal to suppose y into d. And if you have this code, and look at that, this x, what you have computed, whatever you have computed, is it used in the future? Not used in the future, yes or no? It means it is dead. This x is dead, so this is called as dead code. Dead code. There is no use of executing this line because nobody is going to use x in the future. It means x is dead, not live, you can say that. It is, x is not live. But if you look at y you have used here, and z, that might be printing, you might be printing z, that's fine. Clear this point? This is called as a dead code concept. If you try to delete this dead code, the resultant code you can write as y is equal to a plus c and z is equal to y multiplied with d and print z. And this is after elimination of dead code. After elimination of dead code. But can you eliminate dead code just by looking at theoretical concept? No guys, for that you need to do live variable analysis. If you can do which variables are live at every statement, you can delete such statements which are not live. X is not live, so you can delete x is equal to a star b line. So for this you need program analysis. Of course, every optimization you require program analysis, guys. Fine. So in the exam, this is all you require. They will ask you what are the code optimizations you can. There is other kind of dead code elimination, guys, which requires a more patience to test. Suppose you have, if you have, let's say true, that true I'm writing 2 and I'm just writing printf, let's say gate is there, and else printf exam. This is another code. I'm talking about the code only. You know that if is going to be always true, this is always true, everybody knows, and this is never be executed at runtime. Then the compiler can analyze using the program analysis that this is the dead code. This point is never be reachable during execution. Dead code, there is another kind of statement, which is the statement or point which is never be executed at runtime, not reachable during execution. This is a not unreachable code. Unreachable code, guys. So this is an interesting code, but if you eliminate this just simply after analyzing so many things, simply you can write printf gate. Even if statement is not required, and after analyzing the code, after elimination, after simplification, after elimination of dead code, and also I have simplified, because if 2 is so costly, I can directly replace with and I simplified it. And simplification, after simplification you will get just a printf gate. So it's a more interesting code optimization, guys. Fine. Is it clear, everybody? I think you can understand what is happening here. Only you should know what is the name of the optimization. These are two kinds of dead code eliminations. One is that something is dead code because of that is not used in the future, means X is not live, that is called as. But how do you know that? Tomorrow we are going to analyze what do you mean by dead code. What do you mean by dead code? We can analyze tomorrow that. Okay, next one, the common subexpression elimination. You know, for this you can use control flow graph, you can use a directed acyclic graph, you can use program analysis. So many ways you can do this common subexpression elimination, but famous technique is you can use a DAG to eliminate. Directed acyclic graph can be used, but also you can use control flow graph, you can do data flow analysis. Remember, you can do data flow analysis to identify common subexpressions. There are various techniques to apply the common subexpression elimination. Okay, let's look at. Suppose somebody are writing the code x is equal to a star b and z is equal to a plus c and w is equal to a star b, and they want to do something like, you know, z is equal to z into x and w is equal to w plus z, something like that, guys. Now if you look at the code, you can see a star b is computed twice, but you require to understand in between a and b is not changed, then only they are same expressions. They are going to be sub expressions in the given expression, so we can eliminate them by computing once. So if you can design the DAG, you can easily understand, okay, a star b is same. So how do you know that? You need to write the expression, then you will know. Otherwise, look at in between. Look at in between a and b not modified, not having any definition in between. No definition for a and b in between. That means they are common subexpressions. They are common. So what you can do, you can compute once. You can compute once like x, and wherever you have a w, there you can use x. So I am going to use that. Z is equal to a plus c, and w I am not going to. I am going to delete it. So z is equal to z multiply with x, and w is equal to w I can replace now with x. So that means I have saved, this computation is not required anymore. Now this is not required anymore, because wherever you have a w, I can replace this x as it is. So this is after elimination of sub-expression. I have eliminated common sub-expressions. That is, a star b is a common sub-expression. A star b is computed only once instead of twice. Everybody, come on, Vaibhav, good evening, good evening. And this is, you know, very easy in the exam. In previous class also I have helped you how to find out the number of nodes and edges in the DAG. That is one common type of question. This is the second question, guys. Common sub-expression elimination. Okay, but don't apply blindly every time. You need to write expression to understand. Okay, and before going for other optimizations like loop optimizations, let me talk about the plus and iconic subscription. How do we get benefit? And guys, you have so many free classes apart from that, apart from this, and you also have a paid classes. And Unacademy has given you two options. One, you learn as many days you want free classes, but whenever you feel that you are not going in the right direction, you want more, then you can convert to plus, because you will understand the benefits of plus and iconic if you keep on attending free classes. And free classes you will learn a lot, and plus and iconic, they are structured and you can save the time in preparation and you can ace the rank very easily. Okay, now let's move on to the loop optimizations. Loop optimizations are many types, guys. Okay, inside the loop, so far whatever I have discussed, all of them are applicable. Also, additional to that, you have one is the code motion, means you can move the code from the loop to the outside the loop, and induction variable elimination. So what is the induction variable? We will see that. Apart from this, you can do loop merge, you can call loop combine or loop fusion, and you have the loop unrolling, right? The merge or combine or fusion, something like that. So many names for that. Fine. First, code motion. Yeah. First, code motion. So what is the code motion? How easy it is to understand the code motion? So far, I think you can understand when you look at the simple code. The problem is when you look at whole program and looking these optimizations will be difficult. That is the reason you require data flow analysis. Remember, guys. And today we are not doing data flow analysis. We are learning what optimizations you can use in the programs. Okay. Now let me write a loop for. Okay, something you have, I is equal to 0, I less than n, I increment. Suppose you have x is equal to 10 and y is equal to y plus I or y into I, something like that. And you are doing this. Guys, in this code, the x is equal to 10 every time is same, and really do you require to keep x is equal to 10 inside the loop? You can also write outside the loop so that you can save the time moving the 10, right? Or you might be computing something different, but is it always same or not? Even I can write a more complicated code, 10 into a. If a was there some value and a into 10, is it always same or not? Because a never updates inside the loop, so 10 into a is not updated. So this is called as loop invariant. This is called as loop invariant code. It is not going to change. In every iteration, this x is equal to 10 multiplied with a is going to have the same value all the time. But y is getting updated because I is going to increment, so y is also going to be updated. Everybody, guys? So here, what you can do, this loop invariant code, you can move before or after, depends on your code. Sometimes before is good, sometimes after is good, sometimes only you can move before because after maybe somebody might be updating. Okay, that's what I am talking about here. And this code you can write x is equal to 10 multiplied with a. So that I have saved, previously you were executing n times, now you execute one time. So multiplication, n multiplication previously, now we have only one multiplication, guys. Okay, for I is equal to 0. Sorry, guys. I is equal to 0. I less than n, I increment, and you have y is equal to y multiply with I. And you know what kind of optimization we have done? We have saved a lot of computations, guys. We have saved a lot of time. Clear this point? And here previously n calculations, here n times we are doing multiplication. Now only one time multiplication. That's the difference between these two optimizations, or this loop optimization. Right? This is called as moving code out of the loop. So this is called as code motion. code motion. Similarly, let's go for the next one. Induction variable elimination. Induction variable elimination. So what is induction variable first? Right, any variable which keep on updating based on the iteration of the loop, that we call induction variable. Sometimes we write, for I is equal 0. Let me keep here j is equal 0 and I less than 10, I increment, j increment, and I'm doing something here, x is equal to x plus I and y is equal to y into j. And if you look at this code, guys, here okay, let me write this as, instead of 10, let me write n. There are so many variables now inside the program. Now, which are induction variables? Which are induction variables? I, that's directly we are incrementing every time. J also we are updating, and x indirectly, y indirectly. This many induction variables. Who is not induction variable? N is not going to be updated inside the code. So n is not induction variable, guys. Here x, I, y, j are called as induction variables. Either directly or indirectly, that depends on the loop. Even one time the value is updated, it's going to be induction variable, guys. Okay, no need to update in every iteration, but that depends on the loop. Now n never be updated, so it's not induction variable. So guys, for this, can I eliminate induction variables if I want here? And x and y initial values unknown, but I and j both are actually same, right? So you no need to maintain two variables for that. What you can do, I is equal 0, I less than n, I increment, here x is equal to x plus I, x is equal to x plus I, and y is equal to y star I. Now I only I can use. So here I, j are having the same values all the time. So I can delete the j. In place of j, I can use I, because every time I, j values are same in the code. Yes or no, guys? Yeah, this is called as eliminating the induction variable. J is eliminated or I is eliminated. This is your choice. But keep as per the code. J or I you can eliminate. You can replace I with j or j with I. It is your choice. Right, but I less than n is there, so better to delete j. J is eliminated. This is called as induction variable elimination. Induction variable elimination. For that, you should know what is induction variable. Fine. Next, loop match. And this is obvious that two loops we have. Let's say I is equal to 0, I less than n, I increment. Very simple code I am writing, like x is equal to x plus I. One loop. Other loop you have similar kind of code, j 0 to n minus 1, and j increment. Here you have y is equal to y into j. Y into j. Okay. Now how can you merge? How can you merge into one code, guys? Instead of maintaining two for loops, how many statements you execute? So many. Now I can maintain one loop for this. I know that x is going to be x plus I every time, and y is equal to y plus I. So two loops we are merging into one loop, guys. This is one loop and this is another loop. We are actually merging into one loop. Definitely the number of executions you save a lot, no doubt about it, right? Yeah, this is called as the loop merging. You can call loop combine or loop fusion and so many names for the same technique. But so easy when you have two loops which are going same number of iterations, and if the code is slightly easier than difficult loops, then you can do this. But is it always applicable? No, only when such codes are. But who will do analyze? The compiler do the static analysis guys. Okay, at runtime we don't do such analysis, only compile time. Okay, now loop unrolling. It's a very special case, like you have for I is equal to, let's say 1 and I less than or equal, let's say 4n. I increment. Sorry guys, it's not charging. Fine. I increment. So what I'm going to do here, look at something you are writing here, printf gate. And in general, you know what is happening here. Here gate is printed 4n times. 4n times, depends on the value of n. So what you can do here, this 4n you can do half. 4n you can do half. That means 2n. Like for I is equal to 1, I less than or equal to n, I increment. And what you can do, the printf gate you can make twice. You can do the twice, right? You can do printf gate. Of course you can write some other code, but easy to understand using printf. Previously 4n times gate is printed, now also 4n. How do you know that? Each time 2 prints, total 2n times you are going to execute the loop, so total 4n again, right? Result is same, but the speed of the second loop is better than the first one. Here it is slower and it is a faster, and this is called as loop unrolling. And is it possible every time? That depends on what condition you have. And again this 2n you can make n, and then these 2 gates you can write 4 printfs. So again 4n times it will be printed guys. So loop unrolling can be applied any number of times. So this is a one time loop unrolling. If I do one more time loop unrolling, what happens? This is called as loop unrolling one time. And if you do again, what happens? For I is equal to 1, I less than or equal to n, I increment. Here 4 printfs comes here, because this thing will be copied twice. Twice we need to write now. Printf gate. And now this is far better than the second code. This is a more faster than the previous one. And here what we have done, here 2n was there, now we made n, half of it, and this one we copied twice. We got 4 printfs. But this is not applicable all the time. It is applicable only when such codes are available. So this kind of optimizations will help us a lot during the analysis of the program. Today we have learned only code optimization techniques, that's all, like constant folding and constant propagation, copy propagation. This is the copy propagation, variable propagation, and strength reduction, algebraic simplification, common subexpression elimination, dead code elimination, loop optimization, right? In the loop optimization we have seen many things like code motion. You can move the code out of the loop when it is invariant, and you can eliminate induction IV elimination, induction variable elimination, and you have loop merge and loop unrolling. And these are very basic techniques, but in the coming session we will be talking about how to do the program analysis with the help of data flow analysis. So in the coming session we have very interesting, what is this live data flow analysis? Data flow analysis we are going to do on the program. So program can be analyzed with the data. Program analysis is very important topic in MTech level. So we are going to see data flow analysis. In that, main focus is on live variable analysis as per the syllabus guys. But there are so many other analysis too, live variable and reaching definitions and available expression analysis. So many analysis on data. Among them, mainly we will focus on how to do the live variable analysis, guys. So this is the tomorrow topic. The next topic, right, in the next session, and please attend that session, which is very important for you as per the GATE syllabus. And guys, if you want to follow me today, you can attend my class at 6 p.m. Digital PYQ on Unacademy. You can attend, and also 8:15 the TOC PDA construction, guys. And already morning algorithm classes completed on Unacademy, which are completely free. Everything is free, guys. Here, don't assume anything is paid here. No. So languages, 100 questions we have practiced today. That is also free. How to access those classes, guys? Please visit my profile. You can see all classes unacademy.com/DevaGateCSE, and do not forget to use, if you are coming to the Unacademy, use this code to access my free classes, DEVALIVE. You can access free classes, and also you can go for paid, is your choice, but do not forget to attend my free classes on Unacademy. And this is our Telegram channel where every day we share our links, and please follow us. And we have so many free YouTube channels for various engineering students. You can share to your friends if anybody is studying in engineering. And thank you so much, and don't forget to like before leaving, and please do that, and subscribe if you have not done it, and share if you have any friends to attend these sessions. Thank you so much. Bye bye. Take care.